Okay, now let's look at dew point temperature, which is really an even better way to measure humidity. So what the dew point temperature is, it's the temperature you would have to chill the air down to get it to saturate. So in the example in the book here, we have some air, a kilogram of air, and it's at 20 degrees Celsius, and it's holding 7 grams of water vapor. So the question we have to ask is, at what temperature will be 7 all that it can hold? And so to figure that out, you have to look over here. Here's our saturation mixing ratio curve. And we want to know where 7 is all that it can hold. So here's 7, and it looks like it's right about here at about 10 degrees. Okay, so if it gets down to 10 degrees, it should be 100% saturated. So let's look here. So it's 7 grams, 1 kilogram of air, 20 degrees. It's 50% full because it could hold 14, but it's only holding 7. If the air temperature drops to 10, now it's still holding 7, but 7 is all that it can hold. That's the saturation mixing ratio. So it's full, 7 out of 7. But what if we push it lower? Then you're going to have to condense. So at this point, it's saturated, and so the dew point temperature of this air was, what, 10 degrees, right? So it chilled down to 10 degrees, and it started to condense. And if we continue to drop the temperature, then more liquid will condense out. So at 0 degrees Celsius, the air can only hold 3.5 grams. And so that means out of the 7 that were originally in this, half of those have to come out. 3.5 have to come out. So 3.5 grams of water have now condensed, and 3.5 grams are still in the air. So the air is still at 100% relative humidity. It's saturated, but what you've done by taking that out is you've actually changed the dew point temperature. So now the dew point temperature of this air is 0 degrees Celsius. So pretty easy to find the dew point temperature. Find out what the mixing ratio is over here. Go over to the line and down and read off what the temperature is, because that temperature will be saturated. An analogy is my bottle here, right? So the bottle is half full. So this is like the air initially, but as we lower the temperature, then we change the capacity of the bottle to hold moisture. It's like squeezing the bottle. And eventually you get to 100% by changing the capacity of the bottle. And if you go farther, you can leak.